AISL, May 2024. Time Zone 1, Paper 1. Question 1. We are given 6 pieces of data. The mean is just the average of the data. For the median, we arrange the numbers in ascending order. Then, take the average of the middle two values. For the mode, is 2.31, because that is the only value that appears twice. The range is simply the maximum minus the minimum. Part B. We have a new measurement, 1.98 meters, given correct to the nearest centimeter. That means the smallest possible value is 1.98 minus 0.005. Question 2. We have a Venn diagram. Part A. The total number of students is just the sum of all the numbers in every region of the diagram. Part B. The number of students who have not eaten at the Indian cafe is the sum of all the numbers outside the India cafe circle. Part C. The probability that a student chosen at random has eaten at both cafes is the number in the intersection, 13, divided by the total number of students. Part D. Let T be the event that a student has eaten at the Thai cafe, and I be the event for the Indian cafe. We want P of T union I. That's just 31 over 33. Part E. We check whether T and I are mutually exclusive. For that, we look at the probability of their intersection. Since it's not zero, they are not mutually exclusive. Question 3. We are told that 40 cars are expected to be sold in January 2025, and the monthly sales follow a geometric sequence with common ratio 1.1. Part A. We want the numbers of cars sold in December 2025. That's 12 months after the first term. So, we just use the general formula for a geometric sequence with n equals 12. Part B. First, we want the total number of cars sold in 2025. There's a geometric series with 12 terms. So we apply the sum formula with n equals 12. The result is 855. Next, we want the total number of cars sold in 2026. For that, we first calculate S24, which is the total for both 2025 and 2026. Then subtract S12 to remove the 2025 sales. That gives us the net number of cars sold in 2026. Question 4. We have T, the percentage of phone power, modeled by an exponential function, where T is the number of hours after 7 o'clock. Part A. We want the percentage of power at 7. That's just substituting T equals 0 into the function. Part B. We are told that T is 75 at 8 o'clock. So we put T equals 1 and P equals 75 into the formula and solve to find A equals 2.4. Part C. We need to draw the graph of this function. Use the calculator and make sure to label the intercepts. Also, show clearly that the graph passes through the point 175 since that was given in Part B. Part D. Why can the percentage of power P never reach 100? Because it's an exponential function with a horizontal asymptote at P equals 100. So the graph gets closer and closer but never actually reaches 100%. Question 5. This is a standard financial math question. A deposit of 100,000 is made, with interest rate I compound monthly. After 8 years, the amount becomes 150,000. For part A, we want to find I. On the calculator, we enter N equals 96, PV equals negative 100,000, FV equals 150,000, with payment per year and compounding per year both set to 12. Solving this, we find that I is about 5.08%. For part B, the 150,000 is withdrawn under the following conditions. The interest rate is 6.1% compound monthly, and at the end of each month, a payment of 1,000 is received. We want to find the remaining amount after 10 years. On the calculator, we enter N equals 120, I equals 6.1, PV equals negative 150,000, TMT equals 1,000, and again, payments per year and compounding per year are both 12. The result shows that the future value is about 110,867. Question 6. We have a diagram with points A, B, and C. The perpendicular bisector of BC intercepts the axis at 0, -1, and at 2, 0. For part A, we want to find the equation of this line. To do that, we calculate the slope using these 2 points, and since we already know the y-intercept, we can write down the equation directly. Next, we look at the perpendicular bisector of AB, and we want to find point V. Remember, our answer should be given to 4 significant figures. Since V is simply the intersection of the 2 line equations, we can set up simultaneous equations and solve them using the calculator. Finally, in part C, we need to draw the edge of the Voronoi diagram. This is straightforward. We just select the correct sections of the dotted lines from the diagram. Question 7. D is the depth of water, and T is the number of hours after noon. At 3 o'clock in the afternoon, the depth is 7 meters, which is the highest level, and at 9 o'clock in the evening, the depth is 1 meter, which is the lowest level. This can be modeled by a trigonometric function. For part A, we want to find A, the amplitude of the function. That is just the maximum minus the minimum, divided by 2. Next, we want to find B. To do this, we first determine the period. We see that the water returns to the mid-level when T equals 6. So, the period is 12. From this, B is 2 pi divided by the period. Finally, for part C, we want to find the first time after noon when the depth is 3 meters. We set the function equal to 3 and solve. This gives T equals 6.649, which means about 6:39 in the evening. Question 8. We are given the formula F equals 1.8 C plus 32. For part A, we want to make C the subject. This is just basic algebra. We arrange the formula so that C is expressed in terms of F. In the second part, we want to find C when F is 77. That is simply a matter of substitution into the rearranged formula. For part B, the mean of C is 17 and the standard deviation is 9. To find the mean of F, we substitute 17 into the formula, which gives us the mean of F. For the standard deviation, we remember that adding or subtracting a constant does not affect the spread. So, plus 32 has no effect. The only change comes from multiplying by 1.8. Therefore, the standard deviation of F is 9 times 1.8. Question 9. We have a cube, and each sign decreases at a constant rate of 0.2 mm per second. The original sign length is 10 mm, and we want to find the length of one sign after 20 seconds. So we take 10 minus 20 times 0.2, which gives 6 mm. The volume of the cube at that time is 6 cubed, which is 216. For part B, we are given the function for the volume, and we want its derivative. Using the power rule, bring down the index and reduce the power by 1 for each term. That gives us the derivative of V. For part C, we want the rate of change of the volume when t is 20. So we substitute t equals 20 into the derivative we just found. For part D, we think about why the sign length may not always decrease at a constant rate. In reality, the decreasing rate should be proportional to the surface area of the cube. But since the surface area keeps decreasing, the rate of decrease of the sign length would also change. Question 10. For big S, mass m is directly proportional to the shoulder height h cubed. Part A. We want to find an expression for m in terms of h. So m equals k times h cubed. When m equals 64, h equals 0.8, we substitute to find k equals 125. Therefore, m equals 125 h cubed. Next, we want to find m when h is 0.75. Substituting gives m equals 52.7. Now, we are told that energy E is directly proportional to h squared. So, E equals k1 times h squared. We also know that the energy of a lion with mass 220 is k times the energy of a cheetah with mass 64. To solve this, we first find the height of the lion when m equals 220 using m equals 125 h cubed. Then we can write down the lion's energy as k1 times the lion's height squared. Similarly, we write the cheetah's energy as k1 times the cheetah's height squared. Setting the lion's energy equal to k times the cheetah's energy, we solve for k. The result is k is equal to 2.28. Question 11. We have a semicircle, and we want to find the length of arc BQ. First, we note that BO is the radius of the circle, so we can apply Pythagoras' theorem to calculate it. After that, we find the angle BOC by using the tangent ratio in the right-angled triangle. Once we know angle BOC, we can determine angle BOQ. Finally, we use the circumference of the circle multiplied by the proportion of this angle over 360 degrees to find the length of arc BQ. Question 12. We play a game of spinning a needle. X is the amount that a player wins. First, we want to find the expected value of X. This is just the sum of each possible winning amount multiplied by its probability. After working it out, we find that on average, the player loses $2.8 per game. Part B. The game holder increases the winning price for the second game from 5 to 6, and for each successive game, the price continues to increase by 1. If Emmy plays K games and the K game is fair, we want to find K. Since a fair game means the expected value is 0, we consider that the winning price for the K game is 5 plus K minus 1. Setting up the equation and solving, we find K is 8. Finally, why does the game holder still expect to raise money from the games Emily plays? Because when K is smaller than 8, the expected value for Emily is negative. That means the game holder is in advantage.